All right, as we said, I don't need to emphasize the significance because we all are living through it. Just for the past weeks, it seems like months, suddenly it's monsoon season and we have lots of rain. And this happens every year. It's like we're always surprised, no? But this happens every year. In fact, if you look at the data, the visualization, these are the typhoons for the past 50 years. We're really in a special place. This is part of our blessing as the Pearl of the Orient. And tayo talaga, all the typhoons that are originating from the Pacific Ocean hit us first. So we are the barrier to the rest of the Southeast Asia. They should thank us, right? So this is really, I would say, a uniquely Philippine problem. And actually, when we are looking for literature, thinking of parang seeing what studies have been made, it's like no one is studying this. And then you realize it's because the context is different for other countries, right? In the US, they have hurricanes. So it's very different for us, and it's only up to us also, Filipino researchers and data scientists, to study our own problems. The good thing is you can't be scooped. So we're sure that if we publish it, we're the only ones who are trying to solve it. So you see, you try to look at the brighter side of things. So we're visited by around 20 typhoons a year of varying degrees of strength and destructiveness in terms of wind strength or rainfall. And as we know recently, storm surge, right? So you now know the destructive power of storm surges that Typhoon Haiyan, Super Typhoon Haiyan brought in 2013, especially in the coastal communities. And of course, the affected population need relief. Estimated around 11 million people were affected, and then the death toll, although controversial, I saw the figure is more than 6,000 fatalities. So it's an immense scale of destruction, an immense scale of logistics to deliver the goods that these people need. And then we're not even talking about the shelter and rehabilitation and reconstruction efforts. So we're focusing here on the first initial delivery of relief goods to the people who need them. Here's a photo from Bantayan Island, Cebu. We're receiving, of course, the instant noodles. It's another question what we should be sending, no, in terms of nutrition and all. But sige, as long as it's hot and you can eat something. Islands, as we will see also in the results, are very vulnerable because of their coastal nature, but also because of the difficulty to reach them during times of even when there's no disaster, and more so in times of disaster. And what you don't see is the waiting, because in the photo op you see them receiving. But this photo at least shows the waiting for the goods that could take the whole day. And what we don't see here is the waiting time when even before any goods arrive in the first place, right? And the uncertainty of when something will arrive, which can then cause, of course, looting, violence, and other problems. So this is the path of Haiyan, and it's actually a common path of many of the typhoons. So for this particular study, we're going to focus on the Visayas region, which is particularly also interesting and challenging because it's a group of islands. Again, very unique to us. We are large archipelago. Not many countries are large archipelagos. Japan is considered an archipelago, but still it's just one big one, major island, right? And then some islands. But here, just in Visayas, you have 6 big islands plus 3 small islands plus many more small islands. And the logistic challenge, yun nga, di ba, is very different. And at the same time, you know, the transportation network, study of the transportation network is unique. Again, it's only us who will study it because this is where we live. So this is the Visayas region, 3 regions, administrative regions, 6, 7, and 8, 9 major islands, and 16 provinces. Population, according to the 2015 census, around 19.3 million Filipinos, or around 19% of the total population. So the first thing we did is we mapped the town centers. So each city and municipality, there are 39 cities and 369 municipalities for a total of 408 town centers. And these are the dots that you see around. This was the first heroic effort of JC. You may ask, why did we do the whole Philippines? Because nagka-carpal tunnel na siya dito pa lang sa Visayas. No, but we will try to do it for the rest also. But you see, what we did was we didn't map the center, geographical center of the polygon of the municipality or city, right? Because that's easy, but there's nothing there. What we wanted to get were the centers of the population, of civilization, of commerce. So we mapped where the town hall is, or where the city hall is, where the church is. We're in the church. It's my first time. Where the church is, where the palengke is. So we had POIs. And then what you'll see, even from just visually from the map, is that the town centers are coastal, right? And this also, yun nga, underlines the vulnerability of our communities with climate change and the rising sea levels, which also, there's now indication that also is contributing to these more powerful typhoons and apparently habagat rains. Okay, so the idea here is that each of these town centers are potentially places of demand, diba? So parang we're thinking of it as a supply chain. The supply are relief goods, and to get to the demand, which are these town centers, where the people will go and get their relief goods. Of course, you can think about barangay level. That's harder. But the town center level is at least fine enough to start with. So that's the demand. Where would the supply come from? So in this study, we looked at the food hubs with pre-positioned relief goods by the SWD. And we found that there are 4 in Visayas. Basically 1 for Region 6, 2 for Region 7, and 3 for Region 8. And that's supposed to serve this whole thing. And okay, again, there could be more, and maybe the recommendation is that there should be more. But for this study, we assume that the goods will come from one of these 4 food hubs, because these are the ones that are, maintained by the SWD and should be the first responders when something happens. Of course, later on, more supplies will arrive from outside, from Metro Manila, for example, from Mindanao, and even from international aid. But one of the takeaways from this looking at this, that you need to have pre-positioned goods closer to where they're needed. And in fact, all LGUs are required to have such. But it's hard to get data on whether they're really stocked, maintained, etc. Okay, now you have the supply and you have the demand. You have to get the goods from the supply to the demand. And because we're an archipelago, there are 3 ways to do it: by air, by sea is very important, and by land. So for air, we map the airports. There are 16 airports in Visayas. And then we assume that you can go from one airport to another if the airport is functional. Ideally, you have C-130s to do that. But we aren't in the level of counting the C-130, the vehicles yet. But again, that's also a bottleneck. Sea routes. So we mapped 70 seaports, and these are the links. The links are actually routes talaga between these ports. But of course, in an emergency, presumably you can use any port. But more or less, yeah, these are the connections because they are across. For example, you want to cross these islands, you can go through these ports. And then finally, land, roads. Roads are very important, and you can argue, actually I found the figure that we have really low ranking in transportation infrastructure globally or even in the region. And in particular, what I found depressing is that we counted how many bridges there are. Because you could imagine that, you can create bridges between islands. But we found only how many? 2, no? Only found 2. San Juanico Bridge and, okay, sorry, somewhere here, JC's point. But for this whole region, there are only 2 land bridges. Now, in other countries, they even have underwater tunnels that you can drive your own car. I think there's one, like, they've been trying forever to connect Iloilo to Guimaras. And so up to now, you need to take a boat. We did that just recently. You take a boat. It's actually you can swim it in a Ironman day and swim it. So it shouldn't be too hard technologically to connect, but again, so this is to say that this is also really affected by the infrastructure, right? And so we are sort of measuring the quality of our transportation infrastructure. In this map, this beautiful map JC made, actually, you see the thickness of the road it's between the centrality, meaning the more it's being used to go from one place to another, and you can see they're sort of the arteries of these islands. And then, actually, you can also see here, I don't know if it's not clear, from this distance, but we also map the topography, so you can see the mountains, and you can see why, for example, there's nothing here because these are mountainous areas. So you have to go around the island to get from this place to this place. Again, presumably you can actually bore a tunnel through the mountain, right, and make it easier. But as you can see, this is the problem. You have to go around, and so particularly this Antique province, will show up as one of the hardest to reach because of this infrastructure. So methodology, what we did is we encoded all of these as a network, as a graph. Mathematically, a network or a graph is just a set of nodes with links between them. So what we define is all town centers are nodes, and they are linked by roads, by sea routes, or by air routes. If there's an airport, then that node is connected via air, etc. And then we can calculate the travel time between one node to the other. So that's a weighting of the vertices. Of course, there's a distance through the route, and then there's a travel time associated with that distance, which is what we're more concerned with, because you don't care how long you travel, you just care how long you wait for the food to get to you, right? So the first step is just to analyze the baseline scenario. Our baseline scenario is the status quo of the transportation network, no damage from typhoons. So even here, you can see already the state of the infrastructure. But okay, San Juanico Bridge is passable, is not blocked. Tacloban City Airport is working, so you can use it. And this is the map of travel times from the nearest food hub within your region. So there's this administrative constraint, right, that each food hub will only serve the provinces and towns within its region. So we assign all of Region 6 to this food hub, and these show the number of hours it would take to get from here to, say, Antique. For Region 7, there are 2. So of course, we choose the one that is closest in terms of travel time, and we assign you to either this food hub or this food hub. Cebu. I don't show the map here of where you're assigned. Essentially, for example, this part of Cebu is mapped, this part of Bohol is mapped to Cebu food hub. And then, Tacloban City Food Hub is mapped to the whole Region 8. And so, here you can see very red in the northern part of Samar, northern Samar, because it takes a long time to get there, even without any damage, without disaster. So, you could also imagine that this has an impact on their food supply, food prices, etc. So this dark red is actually more than 12 hours. Because this particular town, see, is landlocked. No, so it's more than 12 hours to get from here to there. And we can plot the histogram. So number of town centers versus the travel time. And this goes to 12 hours. And here, we put dot, 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 and then infinite, right? We had to hard code infinity into the plot because they are not connected. These are the islands. There's no regular sea routes, so you need to use small boats. And that's around 10 municipalities. The median is around 4 hours. So you will reach half the town centers in 4 hours. You will reach 90% of them in 8 hours. And so this tail of upper 10%, you need more than 8 hours to reach you, even in normal conditions. So that's a long time to be hungry, right? And then you can also weight this in terms of the number of people that are in those towns, right? Make it more concrete. And here, the people who are living in those islands that are hard to reach are around 88,000 people, actually. So that's small part of the whole population, but that's a lot of people. It will fill this room 1,000 times. 100 times. Thank you. So again, you reach, actually, you see the median is slightly now below 4 because population is more concentrated on the urban areas closer to where the food hubs are, but still, it's a lot of people in the, laylayan. And okay, and now, the situation only gets worse during a disaster. There are many kinds of disasters, but in particular, we're looking at typhoons. So what happens is that roads get blocked and the airports get destroyed. And so for many days, the Tacloban City Airport was unusable because the runway was destroyed. And so it's very critical to get those major roads and major airports to get back functional for the transportation network to become healthy again. But we're physicists, so what we did is we damaged, to simulate this typhoon impact, we damaged nodes randomly along the path of the typhoon. So this is Typhoon Haiyan with a 200-kilometer track because of its, to simulate the impact zone because of its strength. And then along the way, you damage node, along the way, but actually we just drop pins essentially until you reach a certain number of, or percentage of nodes damaged. And we start with 0.125%, and then we increase the damage to 0.25, 0.5, 1%, and our apocalyptic scenario, 5%. So 5% randomly damaging nodes. Nodes here are actually roads or ports. And when that node is damaged, it cannot be used anymore for a route to get from food hub to the town. And then we ask what happens to the travel time. So again, we start with a minimum node damage. Here, yeah, it's all still okay. Well, the yellow is less than 0.25 hours of delay. So para ka lang na traffic between BGC and Makati. But as you increase the number of nodes damaged, even just for 0.25%, you see Antique is already feeling the effect, and also the southern Leyte, and so on, and so on. Oh, and then the apocalyptic scenario. Hindi kayo makatulog. Gray means now is actually disconnected. You cannot be reached. So infinite time. So basically, you need helicopters, right? So we need helicopters. Disconnected. It was not disconnected before, clearly, but now disconnected. So another, of course, the quantitative view of this is through the cumulative distribution function. And now we are plotting fractional town centers. So this baseline scenario, the black line, is the CDF of the histogram that I showed earlier. And now we can show also the impact of as you increase the nodes damaged. And at the apocalyptic scenario, 5% nodes damaged, this doesn't go down. So even as you look at higher travel time, up to infinite travel time, only 80%, a fraction of town centers yet to reach 80%. So you are not reaching 80%, right? So you're only reaching the top 20%, 1/5 of the towns. Those are the ones that are closest to these ones, right? The rest are disconnected, so infinite. Of course, in between, so if you just damage, let's say 0.5%, you can see here, this fraction here are the towns that were disconnected. And you can see here, you can slice it at any travel time. And then this is the view weighted by population. And in the apocalyptic scenario, you're only reaching 40% of the population. So 20% of the towns these towns have 40% of the population. And then so on. Here, it's 10% of the population is unreachable. So what we realize is that it's important to look at the ones that get disconnected. Because if you're disconnected, you're on your own, basically. And so you have to be prepared to be self-sustaining at least for, let's say, a period of time that you can also sort of calculate or estimate when relief will reach you. So these maps show how many times a town gets disconnected over 100 trials. So depending on the trial, so we simulated the damages 100 times, and of course depending on the nodes that get broken, your fate could be better or worse. So again, we increase the damaged nodes, and you see here that by 5%, almost all of the trials disconnect all of these towns. Earlier pala we were plotting the median. So if half of the trials is disconnected, we plot it as disconnected. Okay, the takeaway is this, the impact of increasing the nodes damaged is this, it's a weird box plot. Basically, you can see the range of scenarios that happen for 100 trials. So the upper 95 percentile here is that the travel time delay is already disconnected. 5% of the town centers are already disconnected. And then for the apocalyptic case, the median is already disconnected. Okay, so further work, of course, is to look at these critical nodes and implications. But that's basically the setup and looking at travel time, and then you can see here the effect of increasing nodes. Basically, it's a nonlinear effect because you get to the apocalyptic scenario very fast. So I'll just show, behind the tool set, we used these Python libraries. Of course, the workhorses, NumPy, and Pandas. But in particular for the road networks, we used OSM-NX to convert OSM road shapefiles to a network. And we use NetworkX, which is a Python library for dealing with networks in particular, and then other tool sets. Here is the snippet of code that assigns the nearest food hub to each node, town center node. And please, let's all use PSGC. If you have the chance to use PSGC and share it, please do. And then also to make the plots. And I'll end with an invitation, because these things are, actually if you think about it, they're not so hard and they're actually fun to do. I hope you agree. And the best way to learn and to get into it is to do it yourself, and which I teach these DIY data workshops. One full Saturday, and you actually go through a real-world data set and then use Python to analyze and make charts. Doing it again this June and July. So if you'd like to learn more, you can find me on Facebook, Reina Reyes, and the Facebook page is DIY Data Workshops, or email us at this email address. So that's it. Thank you so much for